Hey guys, Karan this side, and in this video I'll be explaining how singly linked lists work. And from this video I'm starting a small series called as Learn DSA with me. And basically in this series I will be covering each and every concept of DSA. I'm learning DSA myself, so there could be any, you can say, better way of coding stuff or a better way of making you understand. So do let me know your suggestions in the comment, and I will be taking them to heart, and I'll be improving those stuff in the future videos. So before starting this series, I'll let you know what are the prerequisites. The prerequisites are you should understand Python, you should know the basic concepts like list, dictionaries, etc. Along with that, you will need to install IDE, your preferred IDE. I'll be coding on VS Code, and you can use VS Code as well. So when you think about linked list, you can say we'll be starting with linked list. When you think about linked list, the first thing that pops in your mind, it should be this kind of image, and that is a list, small chains connected, you can say small particular hooks connected to each other and forming a chain. Similarly, in linked list we have nodes, and node consists, you can say, a single node consists of two components, that is the value and the edge. Value is the value which we want to store. It could be anything. It could be like Karan, it could be any value such as 1, it could be 2, it could be 3, etc. And the edge is the part which will be containing the address of the second node. So when we point, or you can say when we connect one node to the another node, we are forming a linked list. For example, I have created a small diagram over here. We have particular node, each node is connected to one another, and it is together called as a linked list. Now why do we need a linked list? Like we have lists, we have arrays, then what is the actual need of linked list? So let's move on to the memory and understand how it works. For initializing an array or for initializing a list, we need to have a memory which is empty, which needs to be linearly empty. So as you can see in the first one over here, that we have an array initialized inside the memory which is linear. If we want to initialize another array, it could be possible over here, over here, over here, and over here, like this. Let me write it. And y. So another array can be initialized over here since we have an empty memory over here. Now in the second type of memory, suppose we have already stored a lot of stuff and we need to initialize an array, which is not possible over here. As you see, there are you can say extremely rare places which we can initialize an array, and we are initializing arrays, so we'll need a lot of space. Now when it comes to linked list, we don't need enough space linearly. If the memory is empty, we can directly store it inside the memory. So suppose the node 1 is over here, node 2 is over there, node 3 is over here. Now each node contains two value or two components, that are value and the edges. So value will be stored over here along with the edge or the address to the node 2. So we'll be storing value comma address of node 2. Let me extend this. So value to node 2 will be storing it over here, and similarly in node 2 over here will be storing value and the address of node 3. So each node is connected to one another by, you can say, edge, and together it is called as the linked list. And basically we have two more components inside a linked list, that is a head and a tail. Head will be pointing to the start of the linked list, and tail is the end of the linked list. Now let's move on to initializing a node. A node will be containing, as I said, two main concepts or two main components, that is value and the address of the next node. So let's start from the beginning. Let's initialize a class called as node. In this class we will be doing an initialization function. Here we'll be storing self data. Instead of data, we'll be storing value. We'll be taking a value in order to initialize it. We're taking a self.value. Now if you see over here, self.value is equals to value and next is none. So when we initialize a node or create a node, we'll take a value, we'll insert the value, and the next will be remaining empty. As you can see over here, when we initialize a node, the head and tail will be pointing to the single node, and the next, you can say, the edge will be empty as it is not currently pointing to any of the linked list or any other nodes. Now when we initialize a singly linked list, we'll create a class singly linked list, and we will be just a sec, let me switch off this auto suggest. So I have paused the auto suggestion, and let's start with the implementation. So the singly linked list, when we are initializing the class, we will be initializing a head and a tail pointer. Here we go. Self, we initializing self.head is equals to none, and self.tail, it will be none as well. So when we create a linked list, it will be none. You can say all the pointers, head and tail, will be none, and once we create a node, then we'll be pointing them to over here to the linked list. So self.length will be 0. Now the first function which we'll be creating in the linked list will be an append function. So let me show you how append works. Initially, suppose we have a linked list called as you can say linked list A value. You can say there are multiple nodes connected to each other, and we want to append a value. So if you know the concept of list, then you will know when we do an append, the value is added to the end of the list. Similarly over here, the append function will be adding the value to the end. So the none will be removed. We will be adding this singly new node over here, and once we have added new node over here, we'll be keeping the none pointer to the last node next. So what we'll be initially doing is, if we have 2, then 2 will, which was initially pointing to none, will now point to the new node. Let's say it is 3, and then the none will be like 3 will be pointing to the none. and the tail pointer will also be updated. So you can say tail will be over here now, while it was initially over to the second one over here. I know this might be a little bit difficult to understand. Do let me know if there are any, you can say, points which can be improved. I will be definitely improving them in the second video. So let's move on to the append method. Let's create a method called as function called as append, and it will be taking self comma value. So why we are taking value over here? Because we need to initialize a node as well. So first we'll add a new node, which will be node over here, and then we'll be storing it as, we'll be providing it a value which we have received from this function. Now once new node is initialized, we will check if self.length is equals to 0. Now why we are checking this is basically to check if the linked list is empty. If the linked list is empty, there is no point of, you can say, finding a tail node and then inserting it over here, because the linked list doesn't exist. So let's see over here. We can also check this by a particular way. Like there are 3 different scenarios. For example, if self.length, okay, there is a spelling mistake over here. If self.length is equal to 0, or if we want, we can say like this: self.head, if self.head is none, or self.tail is none. If any of this is none, what we'll do is we'll update the pointers. So self.head will be pointing to new node, and self.tail will also be pointing to the new node, and self.length will be plus equals 1. So what we have done over here is we have created, or you can say we have initialized the linked list. This is our first element. After it is added, we'll be seeing a linked list. Now if this is not the case, suppose we already have nodes initialized, we have multiple nodes, then what we'll do is we'll append the node to the end of the linked list. So for this, how we'll do is we'll create a else scenario where we will be adding this node. So what we'll do initially, as we saw in the example over here, what we did is we pointed the tail node to the new node, and the new node will be pointing towards none. Okay, so what we'll do is similar over here. You can say self.tail.next, that is the address which was initially pointing towards none. If you see over here, next is none, so the last value, which will be the tail.next, will be none. Initially will be pointing it towards new node. Now self.tail will now be new node, and what we'll do is self.length plus equals 1. So what we basically did is initially the self.next we pointed it towards here, pointed it towards the third one, and then once it was pointed to here, we shifted the tail node from the second to the third one. Okay, now initially when we initialized the node, this was already empty, the next one over here, the next was not empty, so now this node is pointing towards here, and the tail value is shifted from 2 to 3. Now before we can initialize the class and print, but we won't get the actual linked list printed. We will need a str function over here. So what str function does is basically when a particular class or instance of a class is printed, then this particular procedure needs to be followed. So let's create an str function. We'll be taking self over here. We will be creating a temp node which will be equal to self.head. We will be creating a result which will be printing the entire result. Your list is equal to. Now we will be creating a loop where we will be, you can say, iterating over each and every node. We'll be starting from the head node over here, and then we'll be moving on to the second node, we'll be moving on to the third node, and then until we reach the end of the linked list. So while temp node dot next is not none, what we'll do is result plus equals, so this will be stringify the value of the node. So temp node dot value, and then we'll check if temp node dot next is not none, and if it is not none, then result will plus equal to str, like this. So we'll be just adding the arrow over here, and then what we'll need to do is update the temp node, or we can say move the temp node to the next node. tempo node dot next, and then we'll return result over here. So this is how we'll be printing the linked list. So after an example you will know. So let's initialize the linked list. New linked list is equals to, let's initialize the class, that is single linked list over here, and then new linked list dot append. We'll be appending values over here like 1, 4, this will be 5th, this will be 6th. Now let's print the linked list. Linked list. Single linked list dot py. So as you can see, we got the result as your linked list is 1, 2, 3, 4, 5 and 6. Now what this function initially does is it iterated over each and every node and added the value towards the result, or we can say into this variable, and then at the end we printed the entire linked list together. Now suppose if we don't have this, what we'll get is, let's see, we'll get an object which is, you can say, containing the address of the linked list or a particular node of a linked list over here. So as you know, an object contains, you can say, a particular address. We want to be knowing like how or if our linked list is working properly or not. That's why we have this str function over here. So once we uncomment it, we'll save it, and every time we run it, we'll get our linked list printed over here. So instead of printing just an address, which with the str function we'll be printing the entire linked list. Now once we have done the append method, let's move on towards a new method that is called as add method, or you can say prepend method. Let's move on to a prepend method. Initially what this will do is, as you can see from the name, we'll be adding the node towards the start of the linked list, that is over here. The value will be adding here. So imagine if we want to add a linked list or a node to a linked list at the start, what we'll need to do? We will be having a new node. Let me copy this. I'll need to switch to a different platform. Yeah, so we will be adding a node over here. Then we have this empty node which will be containing a value, and we have a head value over here, or the head pointer over here. So initially what we'll need to do is we'll have to point this node towards the start of this over here, and then we'll need to move the pointer from here to the new node. So let's see how we can do this. We will be creating a function prepend, and it will be taking value as well. Now we'll be initializing a new node. We'll be sending it a value over here. Here also just a sec. So after initializing the node, we'll check if the linked list is actually empty. As we checked on the append method, we'll check it over here. Like if the linked list is empty, there is no point of inserting a node in the head, while the tail counter is pointing to none. So if self.head is none, then we'll be pointing self.head towards the new node, and self.tail is also is equals to new node. Along with that, self.length is plus equals to 1. Now if the linked list already exists, or if there are multiple nodes inside a linked list, then we'll move it over here and we'll do this. Self.head. Now we'll do, so first what we'll do is, first we'll connect the new node to the start of the linked list and then move the pointer towards the new node. So how we can do that is new node, which will be new node dot next. So the edge will be self.head. We'll be pointing it to the head node of the linked list. Now after the new node is pointed towards the head, we will move the head counter towards the new node. So self.head will be now pointing towards new node, and here we'll also do self.length plus equals 1, or we can remove this part from here and from here as well, and we can do it as a finally statement over here. So no matter what happens, the counter is going to be updated. Okay, now let's do it over here, the prepend one. Let's check if it is working or not. Self.linklist.prepend, and we'll be prepending to the first, and we'll be prepending 100 over here. Let's see, let's run the code and let's see if it is updated. So okay, and dot value have prepended new node is equals to here, and type callable. In the line 24 we have line in the 55th. So in the prepend we have an error, so new node is equals to none value. Okay, so we have initialized node incorrectly. That's what I was thinking, why the node was initialized as none. So now the node is initialized over here, and once we run the code, we'll get the prepend one updated over here. As you can see, we had all the appended over here 1 2 3 4 5 6, and then we prepended the 100 towards the start of the linked list, and we got our linked list updated. So I hope you are understanding this and it is correctly. You can say I'm trying my level best. If there are any suggestions, do let me know. Now what we'll move on is we'll move on to the method called as insert, and we'll be inserting a new element at a particular index. Suppose we want to insert an element over here at an index of 0 1 2 3 and 4. We want to insert at 3, then we'll be pointing towards it, or we will be entering the index and the value over here. So let's start with the function. We'll start with insert, and here we will be taking index and the value, because we want to insert it at a particular index, correct? So we'll be taking it as a value. Now we'll check if the linked list is empty. Self dot head is empty. There is none. Then we will return an error. Exist. Now if this is not the case and the linked list is existing, then what we'll do is we'll check if the index is out of range or not. So we can also add it over here, or self dot length is less than index. Then we'll, okay, this is a different condition, so let's cancel this and we'll add this condition in the next console. We'll self, we'll add the condition over here. Self dot length is less than index. So we'll check if the index is actually greater than the linked list itself, then the adding is not possible. As you know, like in terms of indexes, if we move on to the negative index, it will be adding the linked list or the value from the behind of the linked list. And after that, let's move on to the error part. So let's return an error, linked list, or you can directly say index out of range. Now we'll be inserting, or this is the last condition where we'll be inserting the value to the linked list. So what we'll initially do, or we also have one more check like this, else if index is, you can say, less than 0, then we'll also return an error for this one. Cannot be less than 0. As I mentioned earlier, like if the index is in negative, then we'll be inserting the element from the back of the linked list, but I'm not covering that case in this video. You can say it is a DIY or a homework for yourself. I have already, you can say, learned that and implemented it, but the video will be getting too long if we, you can say, cover all the cases. Now what we'll do is we'll create a new node, temp node, which will be iterating, first we'll be creating a new node is equals to node over here, and we'll be adding the value to it. Now temp node, which will be used for traversing our linked list. So temp node will start from the head node, or the start of the linked list, self not head. Now once this is done, we'll start iterating for range 0, index -1. I hope you are getting, or you know how the for loop works. That's why I said the prerequisite of this video is to learn Python and how it works. Now we'll see temp node is equals to temp node dot next. So we are iterating and moving on to the next node, and once we reach the node which is index -1, now why we are doing index -1 over here is basically we will be iterating our linked list. Suppose if we want to add the new node in the second place over here where the value is 2, we will go over here, we will need to add the new node over here, then the address will be pointing towards here or to the second one, and then we'll be adding it to the third one. So basically how it works is, one second, let me show you here. So suppose we want to add a new node, we will be iterating from start of the linked list towards here. For example, here this is the 3 over here and this is 4. We want to add a new node at an index of 4. What we'll do is we'll move till the index of 3, we will point to the next one towards the new, the third one will be pointing towards here, and then this will be pointing towards the fourth index. Then will be added a new node towards to the fourth one. So I know this is, you can say, quite complicated, or my understand, you can say explanation is a bit off, but you'll get the hang of it. Once we started iterating from here, we'll reach a node which is before the actual index, then we'll add a new node over here, and then that new node will be pointing towards the actual index, so the index is increased. And what we'll basically do over here is, after this we will be like new node dot next will be pointing towards the temp node dot next. So what we did is, after coming towards 2, once we reach 2, we are pointing this arrow towards the new node, and then that new node will be pointing towards 3. So after pointing the new node to the third, we will be updating the temp node dot next, which is equals to new node now, and then we are updating the self dot length parameter to plus equals 1. Now we have completed this function. Let's test it out over here. Instead of prepend, what we'll do is we'll append or insert 100 at the index of, you can say, 0 1 2 at index of 2. Let's try this. Let's see if it works correctly. Yeah, it worked. So at index of 2, if you see our previous run, then we had this, or let's do this. We'll print once again. This will be helpful. New linked list. So if we picture this, before our linked list was like this: 1 2 3 4 5 and 6. At the second index we had 3. So what we did initially is, we started iterating our linked list from the start. We went to 0, we went to 1, and then we stopped over here, as we have kept this in a loop, index minus 1. So we stopped till 1, and then we added a new node towards here, like 2 is pointing towards 100, and then 100 will be pointing towards 3. And this is how we have completed our insert 1. We know how to traverse our linked list from this, so I won't be creating a function for traversing a linked list. We will be creating a function for searching of a linked list now. You can say we want to search an element over here, so we can do it now. How we can do it? So let's create a function. We will be basically iterating over here. I hope if you have iterated over list, or if you have created a function where you are iterating over a list to find a value, we'll be doing this over here as well. So let's move on. What we'll do is we'll check if self dot head is none, then we'll return linked list is empty. Now we'll initialize our temp node, which we will be using it to iterate. Now many of you might get a question like, why are we using temp node instead of head? So if we are using head node, then we'll lose the count, or we'll lose the address of the first node, which is initialized, or which is from where the linked list is starting. So if we move this head counter over here, from here, then what happens is we lose where the first node is. We won't be knowing where the first node is, and that will be a problem because we cannot recover it after it has been lost. So what we'll do is we initialized a temp node, and then we'll initialize an index, which will let us know at which index we had the node over here. Temp node is not none. We'll be moving if temp node dot value is equal to value. So we'll be checking the value. If it is equal to our initial value which we are trying to search, then we'll return this. We'll return found at index. Oh, we can also improve it. Found the node. Found the value at index. We'll list the index, and then if the temp node is not the value which we are searching for, then what we'll do is we'll move on to the next node. We'll moving on to the next node. Over here we'll be also doing index is plus equals 1. So we'll be incrementing the index value as we traverse to the node, and once we find the value which is suitable for our node, then what we'll do is we'll return it, and now we'll write a return statement. If the linked list has been fully traversed and the node is not been found, then we'll say not found. So let's try this now. New linked list dot search, and we'll search. Let's search for 100 now again. Let's see if we can find it, and let's comment them out. Oh, okay, I haven't printed the return statement, so let's print it. So as you can see, we found out the value at index 2, as we had over here earlier. We had inserted the value at index 2, and this is our linked list before searching, and we have already found the value. Now I hope you are understanding, and let's move on to the next function. That will be let's think what we should do is get a value. Yeah, let's cover a function that will be getting a value of a linked list, or getting a value at a particular index. So get value at index, and after this we'll be deleting a node or deleting linked list and all. So what we'll do over here is self comma index. I hope this will be easier to understand. So we can copy the logic of self dot head as none, then we'll return linked list is empty. Now if the index is greater than self.length, then we'll return index out of range. Index out of range, and then we'll move on to our main part for looping in. So how we'll loop in is basically how we did over here, but instead of, you can say, finding a value and comparing it, once we reach the value, or we'll reach a particular index, then we'll be returning the value. So for dash in range index -1, so if we move on to the last one, it won't get in it. Temp node is equals to temp node dot next, and once we reach over here, we'll return temp node dot value. Oh yeah, we haven't initialized the temp node, correct? So over here, temp node is equals to self dot head, and yeah, we are done. So we'll get the value over here. Let's print and let's get value at index. New linked list dot get value at index, and let's search for 2 only. We should be getting 100 over here. Let's see. Okay, we haven't printed this. Okay, we got 2, and let me see why is that. So 0 1, okay, it is because we had this one, index -1. Let's remove this. I just thought, and if you see, we've got 100, which is correct now. So what happens is basically, if we enter 0, we'll get to 1 and that. So basically we have completed this, and now let's move on to deleting of a node from a linked list. So first let's start with deletion of the entire linked list, which is quite simpler. Delete entire linked list, which will be just self. It won't take any argument. And what we'll do here is, if self dot head is none, then already linked list doesn't exist. So we'll write this. I have a bad habit. So we'll return linked list doesn't exist. Now if the linked list exists, then it is simple. Like what we'll do is self dot head is equals to none, then self dot tail is also equals to none, and self dot length is equals to 0. And this is how we'll be directly deleting the entire linked list. So let's delete the entire linked list at the end. This will give you this will be an example. Let's comment them out. After this, we'll be deleting them. Linked list dot delete the entire linked list. We'll call the function, and then I'll try to print it out. Then I'll try to print the linked list, and once we run our function, you can see our linked list is empty, that is what I told you. Like once we remove the pointers, the linked list is nowhere to be found. Like the values doesn't exist, the address is directly been deleted. Once if we try to create a linked list again, that addresses will be again assigned to the new nodes. So this is how easier it is to delete a linked list. Now we'll delete a linked list, delete the value from a linked list, delete a, now yeah, let's do this. Delete a value from linked list. This will take self, this will take value. Now we'll also have this condition over here. If doesn't exist, then we'll directly return that the linked list doesn't exist. Now what we will do is we'll first find the index of this value, and we know that index of this value can be found out via this function we already have, search in linked list. So what it actually returns is, let me see, it returns the index of the function, but we cannot rely on this because initially it is returning an entire string of values, which is not useful. To delete this 100, then what we'll do is we'll loop until we have 2. Then what we'll do is we'll directly move this arrow or the address towards 3. So what happens is over here, if we have this 3 linked list or 3 particular nodes, and this is pointing towards here, and this is pointing toward here. So what we'll do is we will come until we are over here, and then we will directly update this counter or this value connecting towards here. Let's go back here. We'll delete this, and directly this pointer will be pointing, or the address will be pointing towards the new node. So what happens is the middle node gets deleted. Once the pointer is not pointing towards, I'll update the search function, it will be returning just the index. Now we'll directly pass it to this self dot search, and we'll search the value. Now instead of this return not found, will return none. So what we'll do is initially we'll check if the value which we got over here is equals to this. We'll remove this. So we'll check if index is none, then we'll return value does not exist. And if the value is existing, then we'll loop in over here. Once we have reached here, like till the temp node is equals to temp node.next, then what we'll do is temp node.next is equals to temp node.next. So what we basically did here is, suppose we are at 2 and it is pointing towards 100. So what we did, we went to 100, switch temp node.next, and again when we added .next, we are moving to the value of 3. So what we did is temp node.next is now pointing towards the value of 3 over here, to the address of 3. Now let's return. Once we are done with this, we are updating over here, and we'll do this. Delete a value from LL, and we're updating this, and value will be 100. Let's see if it works, then we'll move on. Yeah, and as you can see, it worked. So basically the entire logic was, we just search for the value, and if it does not exist, we just return value does not exist, and if the value is existing, we are looping over the entire linked list until we find the index of the value which comes before our intended deletion value, which is 2. Then once we reach 2, we pointed the next, or we can say we updated the pointer of next to point towards the value of address of 3, which in reason deleted the value of 100. Okay, and this is all. Like, I know the explanation was not quite that great, but do let me know at which point or in what part it was quite difficult. I'll be updating it. I have some planned updation for the next videos and all, and if you need small parts for each and every linked list, because I know the video is quite large, so do let me know in the comments if there are any improvements which you guys need.